The Sun is 4.6 billion years old, and it has enough fuel left to burn for roughly 5 billion more. But what happens after that is a countdown no living thing on Earth will ever describe firsthand. Right now, every second, the Sun converts 4 million tons of its own mass into pure light and heat. It has done this every second since before there was a single cell of life on this planet. But that process has an ending, and the ending arrives in stages, each one stranger and more hostile than the last. Stage 1 begins with brightening, not dimming. Stars like the Sun grow brighter as they age, not darker, because the core slowly compresses and burns hotter to compensate for dwindling hydrogen. In about 1 billion years, the Sun will be roughly 10% more luminous than it is today. That sounds small. It is not. A 10% increase in solar output is enough to push Earth's oceans toward runaway evaporation, thickening the atmosphere with water vapor that traps even more heat. No ice caps. No stable coastlines, just a slow, compounding oven, with the dial turning up every million years. And this is only the beginning of the beginning, because the Sun is not done getting brighter, and brighter is not the same as bigger, not yet. Stage 2 is when bigger enters the equation. Once the core runs out of hydrogen to fuse, roughly 5 billion years from now, the Sun will start fusing hydrogen in a shell around the core instead of the core itself. That shift causes the outer layers to swell dramatically, transforming the Sun into what astronomers call a red giant. A star in this phase can expand to over 100 times its original diameter. Take a star the size of our Sun, strip away its stable core-burning phase, and force it to expand outward instead, and you get an object so large it may swallow Mercury and Venus whole. But here is the unsettling part. Earth's fate in this scenario is not fully settled. Some models suggest the Sun will lose enough mass as a red giant that Earth's orbit will drift outward just far enough to escape being physically engulfed. Others suggest it will not drift fast enough. Either way, distance stops mattering long before engulfment would, because stage 3 is about heat, not distance. As the Sun swells into a red giant, its surface temperature actually drops, but its total energy output skyrockets, since a larger surface radiates far more light overall. Earth's surface, whether swallowed or merely grazed by the outer atmosphere, would face temperatures far beyond anything liquid water can survive. No oceans. No atmosphere as we know it. Just a scorched, airless rock orbiting an ember. If you're still with us this far into the Sun's final chapters, that's worth a like, because the next stage is where the Sun stops being a star that supports life, and becomes something that erases the evidence life was ever here. That evidence-erasing phase is called the planetary nebula stage. After the red giant phase, the Sun will not have enough mass to end in a violent explosion. Instead, its outer layers will drift away gently, expelled into space as a glowing shell of gas that can stretch across several light years. Meanwhile, the core that remains behind will be compressed into something almost impossibly dense. Take the mass of the Sun and compress it down to roughly the size of Earth, and you get what comes next. That next object is a white dwarf. A white dwarf is the exposed core of a dead star, no longer fusing anything, simply radiating away leftover heat into the emptiness around it. A teaspoon of white dwarf material would weigh several tons, held together only because quantum mechanics forbids its particles from being packed any tighter. No fusion, no furnace, just residual heat leaking out over unimaginable stretches of time. But here's the part almost no one expects. This ember will not stay hot forever, and what it becomes is stranger than what it was. Over trillions of years, far longer than the current age of the universe itself, a white dwarf slowly cools. As it cools, it dims, shifting from white-hot to a dull, fading glow. Eventually, in a time frame so long that not a single one has had time to occur yet anywhere in the observable universe, it would theoretically fade into what's called a black dwarf, a cold, dark, inert sphere giving off no meaningful light or heat at all, no warmth, no radiation, no signal, just a dense, invisible corpse drifting through space forever. And somewhere in that impossibly distant future, whatever remains of Earth's orbit, if anything remains at all, would circle this dark ember in permanent, absolute silence. So how long would you actually survive if you could somehow watch this unfold in real time? For the first billion years of brightening biological life as we understand it would already be in crisis, long before any dramatic transformation occurs. The red giant phase itself unfolds over hundreds of millions of years, meaning there is no single moment of ending, only an extended, accelerating decline. You would not experience a sudden death of the Sunday. You would experience an inheritance of consequences, stacked up generation after generation, each one worse than the one before, until there was no habitable inheritance left to receive. And that reframes the entire question, because the sun's death was never really about the Sunday. It's about time scales so vast they make human history look instantaneous by comparison. Every civilization, every recorded year, every named star chart humans have ever drawn exists inside a sliver of time, so thin it barely registers against the sun's total lifespan. The sun has already lived through the majority of its stable existence, and everything described here, the brightening, the swelling, the shedding of its outer layers, the slow fade into darkness, will occur on a timeline that dwarfs anything a single species could ever witness from start to finish. If this walked you through a future almost too vast to hold in your head, that's exactly the kind of scale this channel exists to explore. Subscribe before the next star runs out of fuel, and check the playlist below if you're not ready to leave these final stages of stellar life just yet, because somewhere out there, another star is already further along this exact same countdown.